So introduction. So the control unit, first of all, it has two parts: hardwired control unit and microprogrammed control unit. So before this, let's understand what is control unit. So the control unit is the part of computer that's responsible for instruction execution is called the control unit. Basic principle on which the control unit runs is fetch, execute, rather fetch, decode, execute. So what it does is we throw the instruction at it, and it will first of all fetch the instruction, then decode the instruction, and then it will execute the instruction, and it will send to output device, or it will store in memory. While decoding, it will find any possible errors, as it is written in the second point. You can see it will just keep on cycling through this fetch, decode, execute for each instructions. So this is the control unit. So this is the main components used in the fetch, execute, or fetch, decode, execute cycle. We have memory and a processor. So processor can read or write in the memory. So you can see the bidirectional arrow, and we give the instruction or data to the processor. So processor has three parts. For first is ALU, then some registers and control unit. So the reason we need ALU is reason we need registers, because ALU is basically register. So a bunch of registers. So registers are highly speed, and so they can communicate well with the same size of other registers. So that's why we have registers. And the control unit has program counter, so and instruction register. So instruction register, we have instruction of the will store the instruction, and program counter will have instruction address of next instruction. So the next part is microprogramming. So what is microprogramming? In computer central processing units, microoperations, also known as microops or mu-ops, are detailed low-level instructions used in some designs to implement complex machine instructions, sometimes termed as micro instruction or microcode in this context. Basic principle. The principle of microprogramming is to have a control unit fetch and execute not machine instructions, but micro instruction. So the difference between hardwired and microprogramming is that it has micro instruction and not machine instruction. Like the hardware programming is complex to use. So the next is control unit and microprogramming. It is an alternative to hardwired control unit, provides more flexibility in designing the process and control unit. So hardwired control unit is complex to manage when you want to move on to the for example, you have hardwired control and you want to upgrade it to microprogramming. You will have to change the whole system. So advantage: making change to hardwired control unit implies global change. That is, circuit will almost totally be changed. Hence, it is costly and time consuming. For microprogram control, you just need to change the microprogram itself. There is no hardware associated with it. So the cost and time is reduced. The next so the history and need of control unit and microprogramming. So the short history about microprogramming: it was first used in design of EDSEC computer built by this person group at Cambridge in early 1950s. His approach to microprogramming was based on hardwired and is not the one used today. Right now we are using microprogrammed microprocessor and stuff like that. In April Now, in April 1964, the IBM 360 series of computer, the first important commercial application of microprogramming, was announced. The individual, it was announced for the first computer that implemented microprogramming was IBM/360. The individual members of the family were developed from some basic design using different microprograms. Microprocessors, as I said, are programmed with control stored as an integral part of chip, and usually with this feature being completely transparent to user. So we are not right now using hardwired control unit. We are using microprogrammed control unit. So this is the picture of IBM/360 that was that has even implemented a microprogram control unit. So what is the need of microprogram control unit? Imagine a computer manufacturer making and marketing computer X. If X proves successful, move on to something else, or we'll try to upgrade X till name it X plus or X Pro. The new model has to be faster than existing machine. So it says that if X is microprogrammed, it is easy to design. It is easy to upgrade it to make it work fast. But if X is hardwired, the new control circuits have to be designed and debugged, a much slower and much costlier or expensive process. So the need of microprogramming is very essential here. Applications. So this is the Nintendo 64 graphics card, which has implemented the microprogrammed unit. This is the Sony PS3 circuit, which also has implemented microprogrammed or microcode with help of vector processing and array processing. This is developed by Sony Computer Entertainment (SCE). So this is the actual diagram of PlayStation 2 Sony, which is using vector processing, and it also has microcode application in it. So it also supports backward compatibility with my PlayStation processors. So there are some parallel processors and graphics card also there. So the sources I have used is Sony PlayStation 2, then Wikipedia, some such like that. So thank you.